acetate carbonate reacted with dilute hydrochloric acid according to the following equation, and this is the equation. 1 gram of this carbonate was dissolved in 50 grams of 1 molar hydrochloric acid. After the reaction, the solution needed 30 centimeters cube of 1 molar sodium hydroxide for neutralization. We will be given the density of HCl is 1 gram per centimeters cube. The first question, calculate the number of moles of sodium hydroxide that reacted. But before we go there, it is important that you understand what kind of the reaction is this. Now, this HCl is reacting with the carbonate first, and the remaining HCl is going to react with sodium hydroxide. It means that this acid was in excess. It is more. Therefore, it will react with 1 gram of the carbonate. After the reaction is over, the remaining HCl is going to react with 30 centimeters of 1 molar sodium hydroxide. It is important to understand that. Therefore, calculate the number of moles of sodium hydroxide that reacted. That one is directly from here. We have been given that 30 centimeters cube of 1 molar sodium hydroxide reacted with the excess acid. Therefore, how do we get? We have been given the molarity of sodium hydroxide. It means that this is 1 molar. It means that 1 molar means that 1 mole, this is the moles, because molarity, you understand what is molarity. Molarity is the number of moles in 1 liter. So it means that this one is in 1,000 centimeters cube. We will find out that centimeters cube will contain how many moles, because that's what we want to calculate. So that is 30 times 1, we divide by 1,000, and that one will give us 0.03 moles. So the number of moles that reacted with the number of moles of sodium hydroxide that reacted with excess HCl is 0.03. It is very important to know that. When you have molarity, I can give you another formula you can use. There is a triangle here which says like this, because we have here, right here, molarity. The space is very small. It means increase this space. Molarity, volume in liters. This volume must be in liters, moles. So how do you can use this formula and you will get the same answer. How? So we have the molarity of sodium hydroxide, which is 1. We have the volume. It is. How do you write this one down as moles? Moles equal to molarity. Let me use M times volume in liters. The volume must be in liters. A liter, so it is in centimeters. We convert to centimeters to liters per 1,000. So it will be 1 times the volume, which is 30, divided by 1,000. This one will give you 0.3. So you can as well use this triangle. It is important. Part 2, determine the number of moles. Determine the number of moles of hydrochloric acid used in the reaction with the carbonate. Remember, the number of moles that reacted with the carbonate, we don't know that, but we can get that. First, we were given that 1 gram of the carbonate was dissolved in 50 grams of 1 molar hydrochloric acid. So first, let us find the volume of the hydrochloric acid, the total volume that was used, where the X carbonate was placed to react. We have been given, we know that the density is equal to mass over volume. So we want the volume, the density we have been given, that is 1. So 1 equal to mass, which is alright, we have been given the density of the acid as 1 gram per centimeter cube. It means that 1 gram of the acid is in 1 centimeters cube. So we will find out 50 grams of the acid will be what? So it will be 50 times 1 centimeters cube, 50 grams, divided by 1 gram. So gram, we will have 50 centimeters cube. In short, when we have the volume given in grams, it is as good as centimeters cube when the density is 1, when you are given the density. So you should know that. So now we have that 50 centimeters cube of HCl was used. So we know the molarity of the acid, it is 1, therefore it means that 1 mole is the number of moles in 1,000 centimeters cube. What about 50 centimeters cube of HCl that was used? 50 times 1 divided by 1,000. This one is going to give us 0.05. Remember, this is the number of moles of the original HCl. Now we want to know the number of moles that reacted with the carbonate. Remember, the remaining HCl that was in excess, the number of moles is 0.03. Why? The ratio of sodium hydroxide and the HCl is 1:1. So you should know this. Sodium hydroxide, which reacted with excess HCl, the ratio, the sodium chloride plus water, the ratio is 1:1, meaning that the number of moles of sodium hydroxide will be equal to the number of moles of HCl. We know the number of moles of sodium hydroxide is 0.03. It means that the number of moles of excess HCl is 0.03. Now, if this is the number of excess HCl and the total number of moles was 0.5, now what will be the number of moles of HCl that reacted with X? Itakuwa 0.05 subtract 0.03. Therefore, the moles that reacted with the cup of HCl that reacted with the X carbonate is 0.02 moles. Very important. Next question. Calculate the relative molecular mass of X carbonate. Relative molecular mass, RFM, of X carbonate. Now, we know that the mole ratio from the equation, we have this equation. The ratio of the X carbonate with HCl is 1:2. That's what I've written here. But we know the number of moles of HCl was 0.02. So what will be the number of moles of the carbonate? The carbonate will have a half of the number of moles. Therefore, moles of X carbonate, moles of X carbonate is a half times 0.02. And that one will give us 0.01, and that is the number of moles of the X carbonate. Remember the first triangle in the topic moles, the concept, we have the RFM, we have moles mass. How do you calculate RFM? So RFM is equal to mass divided by moles, which is equal to mass. Remember, the mass of the carbonate was 1 gram. 1 gram of the carbonate was dissolved in its 50 centimeters cube. Therefore, the mass is gram. Therefore, 1 divided by the number of moles, which is 0.01. This one will give us 100. Therefore, the RFM of the X carbonate is 100. Hence, give the relative atomic mass of X. To calculate the relative atomic mass of X, given that carbon is equal to 12, oxygen is equal to 16. So X carbon